Hello everyone. Today I am going to discuss various applications of Opamp. Now Opamp can be used to perform various mathematical operations. For example, it can act as an adder, a subtractor, an integrator and a differentiator. All this is done when Opamp is in the negative feedback. Apart from this, it can also act as a log amplifier or an anti-log amplifier. But today I will be discussing the 4 major mathematical operations which an Opamp can perform. I will be showing you the circuit of each and every operation and the derivation on how I derive the expressions for an adder, subtractor, integrator and a differentiator. So let's see them one by one. So let me start with adder. Let's see the adder circuit carefully. Now adder means addition of 2 voltages. Addition means both the voltages should be positive even at the output end, which means I will be using a non-inverting amplifier. This will be the circuit. Now let's see, applying superposition theorem, when I have only V1 acting, my Vout1 will be R2 by R2 plus R3 into V1 into 1 plus RF by R1, which is the gain of this amplifier. Same way, when V2 is acting, I will ground V1 and my Vout2 will be R2 by R2 plus R4 into V2 into 1 plus RF by R1. In the end, I will be adding both my V01 and V02 to get the final expression for V0, which is 1 plus RF by R1, the overall gain into R2 by R2 plus R3 into V1 plus R2 by R2 plus R4 into V2. Now, when all our resistor values are equal, we will get the expression if my all the R's R1 equal to R2 equal to R3 equal to R4 equal to RF equal to R. When all this is done, I will get V0 equal to, my gain will be 1 plus, both are equal, so 2 into V1 by 2 plus V2 by 2 and 2 cancelled, my V0 will be V1 plus V2. This is nothing but adder. Now same way, let's see the subtractor circuit. Subtractor circuit means we need Vout to be V1 minus V2, which means my V1 should be as it is in the output, but my V2 should be inverted. So for that, I will keep my V1 in the non-inverting terminal and my V2 in the inverting terminal. According to superposition, considering only V1, I will get R2 by R2 plus R1 into 1 plus R4 by R3 into V1. This will be my first equation. Now, grounding V1 and considering only V2, I will get V02 as minus R4 by R3 into V2. Second equation. Now, when I add both of these, I will get R2 by R2 plus R1 into 1 plus R4 by R3 into V1 minus R4 by R3 into V2. Here also, if I assume all my resistors to be equal as R, I will get Vout as V1 minus V2. next most important application is the integrator circuit. Now, this is the construction of the integrated circuit where in the feedback instead of a resistor we have a capacitor. Now, let us apply KVL in this feedback loop. Plus Vc plus Vout is equal to 0. So, from here Vout will be equal to minus Vc. Now, generally voltage across a capacitor is given by 1 by C integral I dt. Now, we know that in an Opamp the incoming current is 0. So, whatever is the current here, same will be the current flowing through this feedback. So, the current here is Vi by R. Substituting that I value in the equation, I get Vout as minus 1 by RC integral V dt. Now finally, let me show you the differentiator circuit. The only difference is we have a resistor in the feedback and the capacitor at the input. And in the same way, after deriving, I will get Vout as RC dVi by dt. I hope you understood all the 4 major applications. Please feel free to like and share the video. Thank you.